Boats, canoes, ships, kayaks, and rafts are used for transports on seas and rivers because they can float. Most of these sea transportations can float as they are made out of wood. However, submarines are large, heavy boats that are often built with steel. So have you ever wondered how they move and float in water? Hi, I'm Kristal, and in this video, you will learn to build your very own miniature submarine to test its different levels of buoyancy in water. You will also identify the various types of energy used when the submarine moves using its propellers. After playing this toy, students will be able to This is the list of materials that you will need when building this toy. Precaution: this toy should be constructed under the supervision of an adult, as this project requires the use of a blade, scissors, and a needle. This project may also require the use of fire instead of scissors according to one's need. When playing with this toy, students will also need to be careful when spinning the propeller because it has sharp edges. The step-by-step procedure of constructing this toy will be provided in the description bar below. This is an example of how the miniature submarine would look like. We believe that this toy is best introduced to students of a lower primary level, as this toy is simple enough for them to maneuver. So, how can the toy be played or used for learning? Well, firstly, this toy can be used to introduce the concept of buoyancy to a classroom. A tub of water will first be prepared by the teacher. A demonstration will be conducted whereby the teacher will be placing the toy at the bottom of the tub. Students will need to figure out why the toy keeps on rising to the top of the surface even though pressure is applied downwards to the toy. The process is then repeated by adding water into the toy and the changes are observed. When the object is immersed fully or partially in a fluid, the upward force applied by the fluid on the object is the same as the weight of the fluid displaced by the object. Unlike a ship, a submarine can control its buoyancy by allowing water to flow in or out, thus allowing it to sink and surface at will. When there is a lot of air inside the toy will achieve positive buoyancy and will rise or float to the top. With just enough air inside, the toy will be at neutral buoyancy and will stay level in water. Lastly, with little or no air inside, the toy will be at negative buoyancy and thus it will sink underwater. After students are able to explain the concept of buoyancy with the toy, teachers can ask questions related to real life. For example, students are to observe a video of a person floating on their back in a swimming pool. The teacher would then pose a question to the students, asking them, what is the difference when the person inhales and exhales? Secondly, this toy can also be used to teach energy conversion. Teachers can begin their lesson by speaking to the students about energy. After observing the movement of the toy in water, questions that can be imposed onto students include: where does energy come from? What are the different kinds of energy involved in moving the propeller? Energy cannot be created or destroyed, but it can change from one form to another. In order for the toy to move, various types of energies are involved. The conversion of energy starts from the child that eats and possesses chemical energy, which will then be converted into kinetic energy when the child turns the propeller. The spinning of the propeller then transforms into potential energy due to the twisted rubber band holding the propeller. When the propeller is released, the potential energy from the rubber band is converted into kinetic energy, which causes the propeller to spin and pushes the bottle forwards or backwards depending on the direction that the propeller is spun. After the students have explained about the energy conversion of the toy, the teacher can ask students how conversion of energy happens in real life. An example would be the conversion of energy when a person standing starts climbing up the stairs or a child on a swing. So, after having learned and introduced to buoyancy and energy conversion, here's an experiment for you to try at home. What happens when you change the length of the bottle or the size of the toy submarine's cavity? Try it and leave your answers in the comments below. Here's our reference list, and thank you for watching.